Okay, in this video, I'm just going to show you how to solve one of these projectile problems. This is actually number 28 from the book, not one of the ones that you're supposed to do, but it's pretty similar. So it says projectile gets launched from here at an angle of 60 degrees with an initial speed of 42 meters per second, goes over here and then lands over here at t equals 5 seconds. So it's probably hard for you to see, but part A says find the height of the cliff right there. So I just want to remind you of some of the things that we're going to be doing here is we're going to be separating out the vertical and the horizontal direction. So in the horizontal direction, we're just going to have the distance, the horizontal distance it goes is going to be the initial velocity in the horizontal direction times time. And that's certainly it. Remembering that this initial velocity in the horizontal direction is related to the overall velocity with a cosine. So we can say that the x position is going to be v0 cosine theta. I guess they have it as theta 0 there. Fine. Theta 0. Theta 0. v0 cosine theta 0 times t. So if we ever want to find the x position. And then in the vertical direction, we're going to have y equals 1/2 negative g t squared plus v0y times t plus y0. So it gets a little more complicated in the vertical direction. And remembering you can substitute in the sine of this angle here with the initial velocity, and I'll just change that to be negative. So in the right direction we have negative 1/2 gt squared plus v0 sine theta 0 plus y0. Okay, so that's just kind of our basic setup. And I'm just going to go ahead and leave these things in as these numbers here without actually writing in the numbers until we kind of get to something we can solve at the end. So for the first one, we are trying to solve for this height h right here. And so what we know is that at 5 seconds, in the vertical direction, at 5 seconds, it's going to be at this height h at 5 seconds. In the horizontal direction, it's going to be way over here horizontally, but we don't really care about that. All we care about is at 5 seconds in the vertical direction, it's at this height h right here. So we're really just trying to solve for what's the y position at t equals 5 seconds. All right, so we're just going to say that y equals, oh, actually, sorry, before we do that, we need to set up a couple quick things. First of all, we got to set where's our 0 point in the y direction. So I think it makes sense to set y equals 0 at the ground level and have the positive direction as going up and have the negative direction as going down. And that I sort of assumed that already when I put this negative in for the g right there. So that's what we're going to do. We're going to say it has 0 initial position and that the initial velocity is also in the positive direction over here. So we're going to say y equals, and then, yeah, we can just start sticking in some numbers here. Negative 1/2, 9.8, I'm going to skip my units, 5 squared plus v0 is 42, sine 60, oops, there's a t there too, missed the t, 42 times sine 60 times 5. And I'm going to look in the book solutions right here, and when you do all this out, you're going to get that y is going to be 51.8 meters if you want to solve all that out. You know, one thing I kind of forgot to do is to remind you all that what you know about vectors, so that this initial velocity going off like that, let me just draw it over here, that if this is our v0, then we get v0x looking like this, and we get v0y looking like that. And then here's our theta right there. And then just remembering that this is going to be v0 cosine theta. Oh, I guess it's theta 0. And this is v0 sine theta 0. That's just kind of more setup stuff that I should have done before this problem. Okay, so part B says find the speed of the stone just before impact at A. So the overall velocity right there. And what we're going to do is, if we just draw a little vector diagram right here, there's the stone just before it impacts. There's its overall speed, which is going to be a combination of a vertical velocity and a horizontal velocity. So this is going to be Vx, and this is going to be Vy. Vx is going to be constant throughout the whole problem. So this is still just V0 cosine theta 0. Oh, maybe I'll write this as like v total or something, vt for v total. And so now we just really have to find out what is vy. So that's pretty easy to do as well. There's a couple ways we could do it, but I think the best thing to do is just to use the velocity formula. So once again, sometimes I just like to write down, make sure that I'm talking about the vertical direction. So in the vertical direction, vy is going to be I guess I'll put g, negative g t plus v0 y. So this is just our regular equation for velocity is at plus v0. So if we plug in for 5 seconds here, this should work out. So we're going to get vy is negative 9.8 times 5 seconds plus my initial vertical velocity right here, which is v0 sine theta. That's what that is. So negative 9.8 times 5 plus 42 sine theta. And then figuring all this out, oh boy, I guess we should probably do this. Oops, sine, I can put the angle in here. Sine theta 0, and then the angle here is 60. So we'll do calculator. Let's see if I can spin my calculator around. Okay, so 9.8, oops, times 5 should give me 49. Okay, good, so this is negative 49 plus, clear that, sine of 60 should be good. Wait a minute, that doesn't look right. Hold on a second here. Is there like modes? I've never really used my phone calculator like this before. And let me see. Is there like settings? No. I don't know. That's kind of weird. What if I just do cosine of 0? Okay, good. What if I do sine of 90? Yeah, something's a little weird there. Maybe I'm in radians? How do I get out of radians mode? Okay, radians mode. How do I get out of radians mode on my calculator here? Oh, no, okay, that's good. But how do I go to like settings, choose theme? Choose theme, no. No. I guess, right? I mean, you guys are you're probably laughing at me right now. Let's see. Clear that. Sine of 90. Should not be 0.89. Sine of 90 should be 1. Oh, degrees? Radians. Oh, okay. Sine of 90. Okay, good. See, that's tricky because it says radians now, but I'm actually in degrees. If I hit that, I'm in radians, and if I hit that, I'm in degrees. Okay, so there we go. Now I can do my 42 times sine of 60. Okay, good. I'm glad we figured that out. So this is going to be 36 point, we'll call that 4, and I'm going to clear that, and I'll say 36.4 minus 49. You can skip ahead on this if you want to. So this is going to be negative 12.6 meters per second, and I'm glad it's negative because looking over here, this should be in the negative direction. So now to figure out my total velocity, I guess I should figure out my v0 cosine theta over here. So this is 42 cosine of 60. 42 times cosine of 60. That's 21. So now my total velocity there is going to be the square root of 12.6 squared plus 21 squared. And you just figure that out. I don't need to actually do that right here because that's just math at that point. Okay, now, sorry, the last part says find the maximum height h reached above the ground. So let me shift over to another piece of paper over here. The maximum height reached above the ground. So all I really care about is this is just a vertical direction problem. And in my vertical direction, I'm just going to kind of ignore everything else right here. This is just v0 sine theta 0, which we already figured out was 36.4 meters per second. And now I just need to have something go up and stop at the top. So I think the best equation to use is just going to be my v squared is v0 squared plus 2a delta, and I'll put y in there so it's the y direction. At the top, when it reaches its maximum height, its velocity is going to be 0. So I'm going to put this 36.4 squared plus 2 times negative 9.8 times delta y. And you should be able to figure all that out. And I'm just looking at the solutions over here. Let's make that a delta. It's a little bit messy. Delta y. And then you can just solve this all out. Delta y turns out to be 67.5 meters. So just one little sample problem there. I'm going to make another video in a minute here and show you another sample problem.